Yes, so now, yes, good morning again. Good morning, all of you. So today I will tell you about the how to do a practical virtually to virtual lab. Okay, so you have to just type in the Google that is VLab. Okay, VLab, and then it will gives you a website that is virtual lab, that is vlab.co.in. Just click on this website vlab.co.in. So it will give you that its virtual lab is an initiative of Ministry of Education, which is under the National Mission on Education through ICT. Okay, so you can read these objectives. Okay, so the first objective is to provide remote access to labs in various disciplines of science and engineering. Okay, so whatever labs you are covering, okay, like for engineering, okay, for first year or second year, when you go for second, third, final year, so this kind of labs are there which you can access remotely. Okay, so this is remote access lab is there. Okay, and why this is required? So the second objective is to enthusiast students to conduct experiments by arousing their curiosity. So students have a curiosity. Likewise, you are from computer engineering departments, and some students have a curiosity about electronics labs, or you can say the hardwares, or you can say controller, Arduino, or something like that. Okay, or some students have curiosity related to the thermal engineering, which is in the mechanical, or related to the combustion or something like that. Okay, so in order to understand, or in order to enthusiast your students to conduct experiment by arousing their curiosity, this virtual lab has been developed, and this lab will provide a complete learning management system. And this is important objective in order to share costly equipment and resources. Okay, what happens generally when you do your practical, so you have limited resources in your laboratory. Okay, likewise we have a list of experiment, or we have for any subject. Okay, for any subject we have to consider, or we have to implement, or we have to conduct 8 to 10 practicals. Okay, apart from that, whatever that resources or whatever that equipment is available, we are conducting those experiments on that particular equipments, or with the help of particular resources. Okay, but virtual lab is the platform where there is I can say sharing of the equipments. Likewise, if you see that renowned institutes like IITs or NITs, they're having multiple of resources or multiple of equipments. Okay, so likewise, so whatever equipments are there, okay, we can share it, that equipment, with the help of virtual labs. So this is what you can say virtual instrument. Some of the labs are there which requires hardware setup also. Okay, so that is also possible through virtual lab. So all these labs are divided into simulation lab, and second one is hardware lab. Okay, so simulation lab, likewise, here we can draw a circuit. So there is if you want to do a certain experiment like VI characteristics of diode, so there is we can say a circuit drawn, and then we can change the value of, you can say, voltage, and then we can consider the current values. Okay, likewise there are some remote labs which directly, or you can say, which access hardware only. Okay, so particularly you can say hardware. Okay, this is not under the simulation lab. So with the help of VLab you can do this experiment. So what kind of broad areas that virtual lab you can say considered? That is all engineering and science. So like electronics and communication, whatever the labs which are covered by this electronics and communication, those are there in the, you can say, virtual lab. Likewise computer science engineering, as you belongs to computer science engineering, I will just click on this computer science engineering after I read out this what are the labs. Okay, the electrical engineering labs are there in V labs. Okay, virtual lab. Mechanical engineering labs are there, chemical engineering labs are there, biotechnology, biomedical engineering labs are there, civil engineering, then physical sciences and chemical sciences. So broader areas, these are covered. Okay, and if I click on this computer science, because you belongs to computer science and engineering, just I will click on the computer science and engineering, and it will gives you what kind of labs are there in the computer science in terms of virtual lab. So soft computing tools in the engineering lab is there, then problem solving lab is there, artificial neural network lab is there, pattern recognition lab is there, VLSI lab is there, computer architecture and organization lab is there. Okay, Then comes down, then we have software engineering lab, data structure lab, okay, computer programming lab, computer organization lab, then speech signal processing lab, computer graphics lab, image processing lab, computational linguistic lab, natural language processing lab, wireless sensor network lab, cryptography lab. So these are the labs, okay, and each lab is developed by a renowned institute, or you can say IIT Kharagpur has developed computers, soft computing tools lab. Triple IIT Hyderabad developed problem solving lab. So likewise, the institute has given their hands, helping hands, in order to develop this particular labs. Okay. So when you go for second year, even in the first year, you have practicals. Okay. You can check just practical. How do you check? Okay. So if you don't know about this, which that if you are looking for particular lab, if it is not, if when and which prod area it is available. So just there is a search button is there here, you can search it like that. Okay, so here I'm going to conduct diode characteristics. Okay, VI characteristics of the diode. So I don't know that lab is comes under in computer, whether it comes under the thermal, whether it comes under the civil. Okay, I know that it is comes under the electronics lab, but just a curiosity I'm telling that I don't know about it, whether this VI characteristics of diode, that particular experiment is conducted. Okay, so just what I will do is I will just click here in the search lab, and then I will write diode. Okay, and then there is a search icon, just I will click here, so I will search it here. Okay, now it's searching and it will give me that no record found. Okay, so then I will move ahead. I will search electronics. Okay, if it is there, it will come electronic, sorry. Okay, so just going back. Okay, I'm going to this first electronics and communication lab. So I'm clicking. Okay, it will come. Otherwise, what I will do is I will just in this Google scroll bar, what I will do, I will select diode. I will write diode here, and then I will type VLab, and then press enter. Okay, in this Google Chrome only. So I will land on this search. Okay, so here you can see that in the very first I got VI characteristics of diode. Okay, and just I will click here, and after I clicking, I will get VI characteristics of diode, this total experiment. Okay, I'm just going back. I'm just clicking on this basic electronic lab. Okay, just click on basic electronics lab. Then it will show you what kind of manuals you see generally in your lab. Okay, so introduction, then lab experiment. Okay, then instruction, technology used. Okay, people feedback. Okay, so I'm not going to that. Okay, so I will go just on the list of experiment first. Okay, so likewise your hard lab manual is there. When you see in your laboratories, likewise list of experiment is there for basic electronics for any subject. Okay, so then there is familiarization with the resistor. So what kind of experiment can be covered? So familiarization with resistor, then capacitor, inductor, Ohm's law, VI characteristics of diode. Okay, so yes, I will click. So there are 17 experiments in the basic electronics virtual laboratory. So I'm not going for that. I'm just going for VI characteristics of diode. Okay, just click on VI characteristics of diode. Then likewise your manual, what you will get, it will gives you a theory. This is what the theory. Okay, when you click on there, you will get a theory. So here you can see that theory is there. Objective of this particular experiment. Okay, VI characteristics of diode. What is objective? That has been written here. The structure of PN junction diode is written here. Then function of PN junction diode in forward bias, that is written. Whatever that information is there, that you can read out. Okay, as already we have finished this. And the forward and reverse bias characteristics of silicon diode has been given. Okay, likewise everything has been given in this theory. Okay, next tab is your procedure. How to proceed for this experiment. That procedure has been mentioned. Okay, so just click on this procedure. You can read out this procedure. So for forward bias silicon diode, you have to set your voltage as 0.2. Then you have to select the diode, what kind of diode, then resistor, then voltmeter which is placed. Okay, So that circuitry is there. Okay, this is what the circuitry. You have to select the resistance, you have to select which kind of diode is there, and then you have to select your VDC, okay, voltage, and then you can take measurement. So this is what the procedure. Then just click on the simulation. So before clicking on the simulation, there is a quiz. Okay, if you click on the quiz, likewise in your lab manual, so it will that test your knowledge. Just click on the start, and then you can see that the questions are there. So predict how all components, voltage and current in this circuit will be affected as a result of following fault. Okay, so you can go through these questions also. Okay, later on you can go. Okay, I'm not going right now. Then it has assignment. Likewise, assignments in your hard manual is there. Okay, like derive an ideal current voltage relationship for a PN junction diode. Likewise, there are, I think, 10 questions are there. This is just a assignment for you. And then references they have mentioned. Okay, so this is what complete lab manual you can say. Okay, so I'm going for simulation right now. Okay, just click on the simulation. Then we have this much options, that is forward bias silicon diode. Then it asks for draw circuit. You can draw circuit, you can plot reverse bias silicon diode. Okay, and then this draw circuit is there. Then same theory is for germanium diode and forward bias germanium diode and reverse bias germanium diode. Right now I'm going for forward bias silicon diode, and rest things I will keep you as a homework. Okay, so just going for forward bias silicon diode. Okay, so in the forward bias silicon diode, you can see that there is circuit has been given. Okay, this is what the resistance. Okay, and then in order to find out the current flowing through this diode or this circuitry, an ampere or you can say ammeter is connected. Okay, and this is your diode. Okay, and in order to find the voltage across this diode, this voltmeter is connected. This symbol is for ground, and this is your voltage across. Okay, VDC, what is DC voltage applied. Now you have to read out the procedure first. Okay, so what is the procedure? You have to select the resistance. So here there is a scroll bar is there for resistance. Here is there is scroll bar for DC volt. Okay, is it visible? Okay, then there is you have to select diode. So just click here. Okay, so there is a drop down menu for selection of diode. So there you will get a number. Okay, so what numbers are there? That is 1n, 2n, 1n4, in 4001, in 4004. Okay, depending upon these values. Okay, this is what the number for the diode particularly. Whenever you go for the market to purchase diode, you have to sell that which particular number of that particular diode. Depending upon that, its voltage is changed. Okay, because this is silicon material, so its value will be changed slightly. Okay, so 1N4001, this is what the diode we generally use in your practicals. So I will select this. It will show you what is the forward voltage for this diode. So it will show you that forward voltage is 0.6. Okay, then this is next one, a DC voltage. So initially I will put DC voltage to 0, that is applied voltage to 0. Okay, so its last value for 0 is 0.2, it is showing. Okay, and then resistance I will initially say, so resistance only I have to fix that resistance. So I will put that resistance that is currently emitting is 1000. Okay, sorry, 100 ohm. Here you can see that value particular 100 ohm. Okay, and then I will um, so yes, so now you have resistance as 100 ohm and DC voltage is 0.2. So whether your diode is having given any current. Okay, so no current is there. Just there are three options are there: add to table, and then plot, and then clear. So I will have to take reading. Okay, likewise in the labs you take readings likewise. So at this particular value I wanted to take reading, so I will just click on the add table. So here that experimental table has been given there, this side. Okay, so there is serial number, then forward voltage. What is forward voltage? What is forward current? Okay, so initially it was a 0. Okay, likewise now just I am increasing this DC voltage. Okay, so some extent. So now the DC voltage is 0.5. Okay, I will increase this 0 point. Okay, I will go back 0.2 and add to table. Okay, so at this particular reading, so you can see that here in the table, so your forward voltage is 0.593. Okay, and then your forward current is 1.99. Okay, I will slightly increase again. Okay, so and then add to table. You can see that your forward voltage is 0.599 and then your forward current is 3.99. Now I will increase again. So what is VDC? Now VDC is 1.4 right now. Okay, and then I will take these values. So when VDC is equals to 1.4, that forward voltage is 0.6 and then forward current is 7.98. You can see that values in your ammeter and voltmeter. Okay, then I'm increasing this DC voltage to 2. Okay, so at 2.1 right now values. So it is again 0.617 and then 50 ampere. Okay, if you increase again more, add to table. Okay, then again I will make increase this VDC and then add to table. Okay, and last value I will take at 5 and then add to table. Now you have taken all the values of forward voltage and your forward current through your ammeter and through your voltmeter. Okay, now I have to plot. So just click on the plot. Okay, so when you click on the plot, you will get one plot here. Okay, so here graph plot is there at the downside of this table. You can see that. Okay, so as your this is what your cut-in voltage is there. Okay, that is 0.6. Your current start exponentially increases. Okay, so this is what, and you can see that this current, forward current, that is in terms of milliamperes, and this is what your voltage. So this is what the forward bias silicon diode we can say VI characteristics. In similar way, you can go back to that particular experiment. Okay, and then you can select that reverse bias characteristics. Okay, for silicon diode, and the same thing is there. Okay, so likewise you have to change that VDC. Okay, or you can say VDC, and then you have to take readings for your VR and IR. Okay, similarly you can go on varying that VDC, and then you have to measure all the values of VR and IR, that is your forward sorry, your reverse voltage and reverse current. Okay, and then you have to check. Okay, I will go to that also. Okay, so and then yes, I'm just clicking on the reverse bias, and then the circuit has been shown that for reverse bias. Okay, so initially I will put that DC. Okay, I will select diode. Okay, the 1N4001 diode, and its VR, that is 30. Okay, that is reverse voltage is 30, and then DC voltage. Okay, I'm applying DC voltage at 0.2, and then resistance, I'll put this as 100. Okay, I will take reading. So add voltage. So at VDC 0.2, I got you can say current, that is VR, that is reverse current is 0.1. Okay, here you can see that in the table, and reverse voltage, that is VR, is 0.17. Then I will change the value of DC VDC and then make a reading. Okay, I got the same current. Okay, but you can see that here reverse voltage is changes to 0.17 to 3.04, whereas your current is same 0.1 microampere. Again I will increase the VDC. Okay, so add to table. Now you can see that reverse voltage is 0.59, current is 0.1. Again I will increase somewhat and then add to table. Again VR is 9.56, current is same. Again I will increase it to 16.15 VDC, then add to table. Again it is 0.1. Again it is 0.1. Okay, 0.1. So now I have got this reading. Okay, so reverse current readings I got and reverse voltage readings I got. Okay, then I will use plot. So I'll just click on the plot. So your plot will be here. You can see that. Okay, so this is what your zero. Okay, so at zero your VR, or you can say your current is, you can say 0.1. Okay, and this is what your voltage. Okay, this plot for voltage, you can see that for your voltage 0 you will get current 0.1. For -5 voltage it is again this value. for minus 10. Okay, so all the values are plotted here. This is what your VI characteristic. So for your reverse bias silicon diode. Okay, similarly when you go back, and then you can go for forward bias germanium diode and go for reverse bias germanium diode. This is what homework for you. You can go and you can check this particular thing. Even you can go for another experiment also, which you have interest. Okay, so yes, so that's all for today. I will stop right now.